Today we will be finding quotients of multi-digit numbers using an area model to find partial quotients. Okay, we're starting with this problem, 154 divided by 11. Down here I've got the start of an area model. First, I'm going to estimate just to see kind of what I am looking for. 154 would round to about 150. 11 would round to 10. Using what I know about powers of 10, 150 divided by 10 is 15. I know that the quotient of this equation will be around 15. When using an area model, I know that area equals length times width. Using the relationship between multiplication and division, that tells me that in this model, the area, the total space that it takes up, is 154 square units. And I'm given one of those dimensions. I'm told that one side is 11 units. I'm going to label that over here. Again, using that relationship to find this area, that means that this 11 times whatever this length is here should equal the area of 154. So 154 equals this length 11 times something here. Okay, so if all of this model equals 154, I'm going to write that on the inside. I know that the total area on the inside is 154 square units. I am going to try to figure out what this dimension might be. Over here on the side, I might come up with a few options. I call this my division menu, thinking about this 11. This has to be a multiple of 11. So I'm thinking things like, I know, of course, that 11 times 1 equals 11, which means that 11 times 10, I could put a 0 here and a 0 here. I know that 11 times 2 is 22. Another really common one would be 11 times 5 equals 55. Kind of keeping these in mind. I would love to get as close as possible to this area so that I can have less work to be done. I see here in the number 154, I have 15 tens. 15 tens right there. With my number 11, what could I get that would be close to 15 tens? Looking at my division menu here, if I were to make any of these factors multiples of 10, 11 times 50, that would give me 550, and I know that that is way too big. Same thing here, if I were to make this 20 by putting a 0 here, this would be 220, that's way too big. Remember up here in my estimate, I knew it would be somewhere around 15. Well, that only has one 10 here. So if I were to do 11 times 10, that would give me 110. That's as close as I can get to this using my tens without going over. So I'm going to say, I'm going to break this up to a dimension of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Starting to look just like an area model we would use for multiplication. And 11 times 10 is 110. That tells me that in this section of the area model, there are 110 boxes. But I know that's not all of them in the entire area, so I'm going to subtract to see what I have left over. 4 minus 0 is 4. 5 minus 1 is 4. I'm going to draw my arrow over here. That means that in this section of the area model, there are 44 boxes remaining. So now I'm looking for the length of this section here of my area model. Well, I know that 11 times 4 equals exactly 44. So here, the dimension must be 4 because this is length of 11 times a width of 4. And when I subtract, I see that I do not have any boxes left over. I have counted or used every box in this area. So up here at the top, this was 11 times 10 and 11 times 4. We have multiplied 11 times 14. So if 11 times 14 equals 154, then 54 divided by 11 equals 14. My estimate was 15. This quotient is a reasonable answer. Here's another look at our problem 154 divided by 11. Here is a more accurate area model that has every unit defined. If we look here, we can see that this has a length of 11 units. And as we were dividing, we found that we did 11 times 10 up here, and that got us 110 units. So if I were to shade that in, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can see that all of these orange squares, this is 11 times 10, that is 110 units. Then over here, when I see what is left over, I see that here's 11, and there's 1, 2, 3, 4 columns there. I'm going to shade those in a different color. So now this purple section has a length of 11 and a width of 4. That tells me that there are 44 square units in the purple section. So now with my area model, I can see that this length 11 times the width of 14 will give me a total area of 154. In this example, we will be dividing 576 by 24. We're using an area model. We know that area equals length times width. When we see a division equation, we know the relationship between division and multiplication says that if area equals length times width, then area divided by either this length or the width will equal the other one. So in this case, I have written area divided by length equals the width. So looking at this model, we have our total area, 576. I'm going to write that on the inside. Divided by this length of 24 is going to equal the width across the top of this model. My goal is to get as close as possible to 576 as I'm trying to find my length and the width to minimize the steps required to solve this. I'm going to come over to the side and I'm going to create what I call a division menu, some options. I know that 24 times 1 is 200. Nope. I know that 24 times 1 is 24, which means if I were to take this and multiply it times 10 with a 0 here, it would be 240 with a 0 here. 24 times 2, well, 2 times 4 would be 8, and 2 times 2 would be 4. I'm going to jump down to 24 times 5 because I can multiply that really quickly. Multiplying by 5 is easier and faster for most of us than multiplying by other digits. So 5 times 4 is 20. So that would be a 0 here. I'm going to hold that 2 to add in next time. I'm doing the standard algorithm just kind of sideways. 5 times 2 is 10, plus the 2 from last time is 120. And then, of course, I could keep going, but I'm just going to pause there for a moment. As I look, I'm looking at these tens. I have 57 tens. So I see that 24 times 10 would be 240, or 24 tens. And that would work. I could do that. But let's see if I can get any closer. Looking at the next one, 24 times 2 is 48, which means 24 times 20 would be 480. That's 48 tens. That's pretty close to 57 tens. Let me try 24 times 3 really quick. 3 times 4 is 12, so there'll be a 2 here. Hold that one to add in next time. 3 times 2 is 6, plus 1 more is 7. So that means that 24 times 30 would be 720, 72 tens. That would be too big. So I'm going to go back here to the 24 times 20 and use this 480. So 24 times 20. That tells me that I'm going to kind of mark this off here. In this section of my area model, our length is 24 and our width is 20. That's going to use up 480 of those units. But I didn't find the entire area, so I'm going to subtract and see what I have left over. 6 minus 0 is 6. 7 minus 8. I can't do that, so I'm going to regroup. I'm going to use this 100. So now I have 400 here. I'm going to pull those over here. Now I'm going to have 17 tens. 17 minus 8 gives me 9. And 4 minus 4 is 0. So within this area model, I have 96 square units remaining. Okay, so I'm going back over here to my division menu, trying to find something as close as possible to 96. So right here, I have that 24 times 5 gave 120. That is too large, so I'm going to multiply by something smaller than 5. Here I have already done 24 times 3. Remember, without that 0, 24 times 3 was 72. And that's lower than this. So now I'm going to try something in between. I'm going to do 24 times 4 to see if I can get closer to 96. 4 times 4 is 16. 4 times 2 is 8, plus 1 more is 9. Right here, I got exactly 96. So in this section of my area model, the length is 24. This width is 4. 24 times 4 gave me exactly 96. And here I can show by subtracting that there is nothing left over. There is nothing remaining. So area equals this length times the width. This 576 equals 24 times this. Here I see 20 plus 4. That is 24. To double check my work, I can use multiplication. I am trying to prove that 24 times 24 equals 576. 4 times 4 is 16. 4 times 2 is 8, plus 1 more is 9. I've added that one, and I'm finished with multiplying by this 4. I'm moving over a place value, so I'll put a 0 here. 2 times 4 is 8. 2 times 2 is 4. Getting a little crowded over here. I'm going to add those partial products. We have 6 here, 17. Okay, I have proven that 576 divided by 24 is 24.